Today's lessons is on angles, and I'm going to pre-teach the vocabulary. Okay, so for my goal is I want to be able to name angles by the proper word, know what the algebra is for the angle, and I also want to introduce two more postulates, the protractor postulate and the angle addition postulate. All right, so let's start. I begin with, how do I name an angle? So by definition, an angle is a set of points consisting of two different rays that have the same endpoint called the vertex. The rays are the sides of the angle. So here's my vertex right here. And I have two rays. I have ray AB and ray AC. I have a couple different ways I can name my angle. I can name my angle by just the vertex. I can name my angle by a number on the inside of the angle. So this would be angle 1. Or I can name my angle by a point on the ray, the vertex, and then the point on the other ray. But the vertex must be the middle letter. So I can name this as angle CAB or angle BAC. The vertex must be the middle letter. My angle has two parts. I have the interior, which is in between the two rays, and the exterior, which is outside of the two rays. All right, so let's start going down. What kind of angles can we name? So the first type of angle I'd like to talk about is an acute angle. So an acute angle is where my measure is greater than 0 and less than 90. So I can write that as an inequality like this. Okay, here's my vertex. So I'm greater than 0 and less than 90. Okay, the next angle I have is called a right angle. And I'm going to use the symbol here. Oops. Right angle. And a right angle is a measure of exactly 90 degrees. Here's my vertex. And I show it with this symbol to show I have 90 degrees. And we show that, and we call that perpendicular. My two rays are perpendicular. Okay, so this is an acute angle. Let's talk about my next angle. My next angle is called an obtuse angle. Here's my vertex. An acute or obtuse angle is greater than 90, but less than 180 degrees. My last angle is called a straight angle. And this is an angle where I am, these are opposite angles or opposite rays. So here's my vertex. So this is an angle that is exactly equal to 180 degrees. Okay, the two postulates I'd like to review. So a postulate means I'm accepted without proof. So the first one is called the protractor postulate, and this is just like the ruler postulate, but for angles. So this says the measure of angle AOB is equal to the absolute value of the difference between the real numbers matched with ray AO and ray OB on the protractor. So if we notice, I have two different ways I'm measuring here. So I'm starting here at 0 degrees, and I'm going all the way around here. Excuse me. And I go to 180 degrees. And I have another set of markings on the inside, and they're in reverse. So if we see this is 0 degrees, and I'm going to go all the way around to here, and I end at 180 degrees. It doesn't matter which side you use to measure with, but you have to use the same numbers. So just for ease, I'm going to actually just use the outside numbers, but you are welcome to use the inside numbers. So if I'm looking here, I'm looking at, this is 10, 20, 30, 40. So this ray is at 40 degrees, and going all the way around, this is at 180. So the absolute value of 40 minus 180 is 140 degrees. So this angle AOB, is 140 degrees. Right, the angle addition postulate is similar to the segment addition postulate, where I can say I add my parts together and they equal the whole. So I can do the same thing with angles. If P is on the interior, so that's on the inside of angle RST, then the measure of angle RSP, here's angle RSP, plus the measure of angle PST equals the whole thing. So this is from RST, the whole thing. Okay, that's the end.